This is the semester exam review, problem number 8. Before I begin number 8, I want to refresh your memory on the difference between consistent and inconsistent and dependent and independent. So, if you solve a system and it has one solution, only one solution, then it is said to be consistent and independent. All right, if you solve a system and it has infinite solutions, then it is consistent and dependent. And if you solve a system and it has no solutions, then it is inconsistent. All right, so let's look at problem 8. It says use elimination to solve the system of equations. Identify the system as consistent or inconsistent. If the system is consistent, state whether the equations are dependent or independent. So, to use elimination, we want one of the variables to disappear, so I'm going to try to get the x to disappear. That means I'm going to take the bottom equation and I'm going to multiply it times a -4. Now, why a -4? Because a -4 times a negative x makes it a positive 4x, and when I add it to a negative 4x, then the x is going to become a 0. So that's my goal, is to have the x become a 0. So I'm going to distribute that -4. So I get a positive 4x minus 20y equals a positive 52. Now I'm going to bring the top equation, which is a -4x minus 15y equals a -17 down, and I'm going to add them together. 4x and a -4x is 0, so the x has been eliminated, which was our goal. -20y and a -15y is a -35y equals, and 52 minus 17 is 35. Now divide both sides by a -35. And we get y equals a -1. Now we're not done. We found the y value, but remember our solution is an ordered pair, and we have the y value, which is a -1. Now we're going to find the x value. So to find the x value, I go back to one of the two original equations. It doesn't matter which one. I'm going to take the second one, and I'm going to rewrite it. So the opposite of x plus 5y equals a -13, but I know the y now, so I'm going to take that y out and I'm going to replace it with a -1. So I get a -x plus 5 times a -1 equals a -13. That gives me a -x minus 5 equals a -13. Add 5 to both sides, I get a -x equals a -8, and divide both sides by -1, and I get x equals a positive 8. And now I have my x value, so the solution is the ordered pair 8, -1. Again, I highly recommend that you check this solution by plugging it into, not the one you use, not the one I have highlighted, but the other equation. Plug in the 8 and the -1 to do a check. All right, let's go to the second equation. For this one, in order to make the x disappear, I'm going to multiply the top by 5, top equation by 5, and the bottom equation by 2. So then I distribute those, and remember to distribute it all the way across. So in the top equation, I'm going to get 10x plus 16y equals 30. I don't know why I said 16. Should be a 40. And then distribute the 2, and I get a negative 10x minus 20y equals 30. And again, my brain just isn't working right today. I've got a 2 times negative 20, which is a negative 40y. Now add them together. When I add them together, 10x and a negative 10x is 0. 40 and a negative 40y is 0. So I get 0 equals. And then on the right-hand side, I've got 30 plus a negative 30, which is also 0. So 0 equals 0. When does 0 equal 0? And the answer is always. And if it always equals each other, then there are infinite solutions. Now, my math lab is going to want to know that there are infinite solutions, but that's not all it's going to want to know. It wants to know an algebraic representation for them. So we're going to let the x value be x. Now, take one of the two equations. It doesn't matter which one. Again, I'm going to take the one that looks easier to me, which is the 2x plus 8y equals 6. And I'm going to get x by itself. I'm sorry, I'm going to get y by itself because I'm trying to find the y value now. So I'm going to subtract 2x from both sides. That gives me 8y equals a negative 2x plus 6. Divide both sides by 8. I get y equals the negative 2 over 8 reduces to a negative 1 over 4x plus, and 6 over 8 reduces to 3 over 4. And there's the y value. So the y value is a negative 1 over 4x plus 3/4. So there is an algebraic representation of the solution. Now, I think my math lab sometimes puts the y value for you, and then you would solve for x, but it would be the same procedure.